Okay. Y'all are getting recorded today, so behave.
No problem.
You better than most, because you're the closest. Alright, so, huh?
Isn't Canyon the closest?
As the crow flies, I'm not sure. Pretty close. Okay. Any questions over this? All good. All good. Okay, then we're going to move right in to our notes for today. I do want to remind you guys one thing. 15 and 16, that's finding partial sum when they've given you the terms of a sequence. So sometimes if the sum that they're trying to get you to find are more than the terms they've given you, you just have to find the pattern and go. It's like the first pattern I think was subtracting 7, and the second pattern was perfect cubes, right? So you had to find those patterns, and then of course you could find the ones they wanted you to find. But then that last group from 17 on, that was summation, which you find in your calculator, alpha, Windows, number 2, and you can just type those in. The only one that was tricky was 23. Remember what we said about it? It all has to fit inside the original parentheses that your calculator gives you when you type in alpha window number 2. So, Devish, y'all doing okay back there? Okay, then we're going to move into this. How do y'all pronunciate this word right here? How do you say that word? Yeah, right? It's always been arithmetic. When y'all think about the word arithmetic, what do you think about? Huh? Did Ian say something inappropriate?
I said arthritis.
So you think about arthritis when you see the word arithmetic.
Yeah, it's sort of like sound the same.
Well, I mean, it both starts with AR, so I guess maybe there it is. Anybody else think of something when you hear the word arithmetic? Math? Yeah?
Yes. Exactly.
I think of adding and subtracting.
Why?
Because that's what I've always thought arithmetic stood for. Adding and subtracting. I don't know. Anyways, we don't call it, when we talk about it as a sequence, we don't call it arithmetic sequence. We say arithmetic sequence. I don't know why it changes its pronunciation, but that's what I've always called it. It's called arithmetic sequences.
That's like worse than finite.
But it's better than finite, though. Maybe it's worse than finite, but it's definitely better than finite.
It makes more sense.
Oh, yeah, sure. We'll go with that. Makes so much more sense. Yeah.
Is this the same word as
Keep telling yourself. Y'all agree?
Yeah.
Well, y'all are wrong, too. Remember, this is a classroom of I'm right. And not y'all. So, just don't forget that. All right. Anyways, with an arithmetic sequence, we got two types, okay? Arithmetic and geometric. With an arithmetic sequence, what we have is, we have a sequence in which the common difference, or the difference, so it's a sequence in which the difference between consecutive terms is constant. So let me explain. There was an example that we've done where the change between each term went like this. It went 3, and then 5, and then 7, and then 9, and it definitely followed a pattern, correct? But was that change constant? No, it was a consistent change, but it wasn't a constant change. Constant means what? It changes the exact same way. Just a little difference in the terminology, okay? Constant means it would be adding 4 every time. So the difference between every term would be adding 4, adding 4. That's an arithmetic sequence. Or just as easily, it could be subtracting the same number over and over again. Maybe it subtracts 5 every time. That is the description of an arithmetic sequence. It is a sequence in which the difference between terms is constant. So, when it comes to arithmetic sequences, like I told you guys a couple days ago, we don't have to guess anymore on what the equation, what the explicit rule for that arithmetic sequence is. We can write an equation for it. And one of the big parts of writing the equation is this thing that we call a common difference. You find the common difference using the equation a sub 2 minus a sub 1. What does that mean? A sub 2 minus a sub 1. Yeah, it's the second term minus the first term. That's how you find your common difference. Okay? So, for example, on 1 through 6, it's a group of problems that ask us to determine whether the sequence is arithmetic. If it is, identify that common difference, and then give the next 3 terms. So I actually just start with the common difference. Again, how do I find the common difference? We subtract the second term, which was what? 8, by the first term, which was 5. What is 8 minus 5? And then we check. We check to see that it truly is doing what every time? Going up 3, adding 3. So what is 8 plus 3? Plus 3? Plus 3? So is this arithmetic? Absolutely it is. Absolutely. So therefore, we can find the next 3 terms by simply continuing to add 3. 17 plus 3? Plus 3? Plus 3? There we have it. Okay? Arithmetic sequences. Go right below it. I would try to find the common difference, taking the second term, which is, and subtracting the first term, which is, what's 2 minus 1? So we want to make sure that this thing's going up 1 every time. What's 2 plus 1?
3.
Okay, that's good. 3 plus 1?
4.
Not good. So what's that mean?
It's not
This is not arithmetic. So is my common difference 1? No, because it's not arithmetic. So can I find my next 3 terms? No, because it's not changing consistently from one term to the next. Follow? Are y'all good with this? Now sometimes you have to deal with numbers that are common differences that are not positive, but instead are negative. Look at number 2. How do I find that common difference?
Subtract 7.
Well, that's what it is. How'd you find it though? 16
minus 23.
Minus 23, which sure enough is minus 7, negative 7. So instead of going up 3 like number 1 did, this thing needs to be going down 7 every time. Well, what's 16 minus 7? 9 minus 7? 2 minus 7? So is this an arithmetic sequence?
Yes.
Absolutely. So let's find the next 3 terms. Might be a little harder because we're dealing with negatives. What's negative 5 minus 7? Negative 12 minus 7. Negative 19 minus 7. Negative 26. There they are. Okay? Really, really simple stuff. Number 4 has, it's not, I wouldn't say it's a trick, but just don't forget, if your numbers are already negative, just follow your formula. It's second term, negative 8, minus first term, negative 6. Yes, minus negative 6. What does that do? Turns to plus, so negative 8 plus 6. So this thing should be going down 2 every time if it's what? If it is an arithmetic or arithmetic, I don't care, sequence. Alright? We will accept arithmetic or arithmetic. We won't accept finite and finite. Okay? Only one of those 2 we will accept. But arithmetic and arithmetic we'll take. Keena.
You just said eight.
I am. So does this thing keep going down to? Yeah, so it is arithmetic. So we keep it rolling. What is negative 14 minus 2? Negative 16 minus 2? Negative 18 minus 2? There's my next three terms. All right, so number 5, if y'all look at it, it's not arithmetic. Number 6, I didn't even check whether it is or not. Is it going up to 12 every time? Yeah, it is. So that one would be. All right. Have we covered enough of these? Then let's move on to the next part, which is really the most important part. Remember the other day when we were writing equations, we were just having to wing it, right? And that, kind of presented a little bit of problem for some of us because we were just trying to overthink, sometimes we overthink some things. The reason these are easy is because it's a formula, and you follow that formula, and it writes the equation for you. You don't have to think. And here's what that equation is. A sub n equals A sub 1 plus n minus 1 times d. And we know what all those pieces of the puzzle are, right? A sub 1, what's that?
First term.
That's my first term. N right here, we're just going to leave that there as a variable. Remember, these are explicit formulas. Explicit, not recursive, explicit. So n will be left in the equation. So the only other thing I need to fill in is the what? Common difference. The common difference. So when we move into this next section, do I have to check to see whether or not it is a sequence? When I move down to this section, do I have to check to see if it is a sequence? No, because what does it actually say? It says, write a rule for each sequence. It tells you it's a sequence. So here we go. We're going to write a rule. Now, what are the two pieces I need to write the equation? I need a sub 1. Do I know a sub 1? Do I know my first term? What is it in this problem? Negative 5. And I need one more piece, and that is the common difference. So it's not right out in front of you. Most of y'all probably see it, and that's great. But let's find the common difference. Second term, negative 1, minus first term, negative 5. What happens to minus negative?
Turns into positive.
So what's negative 1 plus 5?
4.
So my common difference is 4. All right. Then are y'all ready to write your equation? With all arithmetic sequences, when you know the common difference and you know your first term, your equation is simply a sub 1. What is it? Plus n minus 1 times 4. Now look, y'all have been solving equations for a long time. What has to come first to try to simplify this equation? Okay, like you said, we're going to distribute the 4. What is 4 times n? So positive 4n. What is 4 times negative 1? All right, so that's the first thing I do. I distribute the common difference. Okay, now we're done. We got one last thing, and here's what I want you all to do. Okay, I want this to be consistent with y'all just like it is with me. Let's start with our variable part. What's my variable part? 4n. Let's put it out front. And then we'll combine our like terms, which would be negative 5 minus 4. What's that? So, what we call explicit formula that represents this sequence is positive 4n minus 9. That's it. It's an explicit formula. One more time. It's an explicit formula. So if the question says, hey, find a sub 24, how do we find a sub 24 in an explicit formula? You plug in 24. That's how we did it. right? To find the 24th term, we plug in 24. So I'm going to go a sub 24 equals 4 times 24 minus 9. That's how we do it. What is 4 times 24? 96 minus 9. So a sub 24 equals 87. Yes, sir.
Instead of doing it like how you just did the little distributing and all that stuff, you just plug in the n as the 24 at the top.
If you were only finding the 24th term, absolutely. But it also asked me to do what? Write a rule. So did y'all hear his question? He's saying, instead of doing what we did, could we have just plugged 24 into n? If they only asked me to find the 24th term, absolutely. But since it said to write a rule, I needed to write the rule first. Okay? But you absolutely could have done that if all they said was find the 24th term. Okay? So great question. Great question. All right, let's do number 8. And then we're going to move along. So what do I need to do right off the bat, y'all? Find the common difference. Second term, 11, minus first term, 20. What's 11 minus 20? Negative 9. All right, here we go. Let's write our equation. A sub n equals a sub 1, first term, 20, plus n minus 1 times our common difference, negative 9. What are we going to do first? Distribute the negative 9. Bring the 20 on down. What's negative 9 times n? And what's negative 9 times negative 1? Positive 9. So what are we going to lead off with? The negative 9n, our variable part. And then what's 20 plus 9? So there's my equation. Negative 9n plus 29. And what's the question asked me to find?
15th term.
The 15th term. So we plug in what? 15. We plug in 15. So negative 9 times 15 plus 29 equals, type it in, negative 106. So, writing equations, pretty easy, right, for an arithmetic sequence? Right?
Yeah.
Okay. All right, so let's flip over to the back. We're going to skip this first section just for a minute. We'll come back to that in a second. And let's go down to right here where you see this arithmetic series. You see, there is another equation I could show you today that would allow us to find the sum through a specific term. But I think it's unnecessary. I think it's unnecessary because why learn another equation when we have learned enough already to find the sum using what we learned yesterday? What did we learn yesterday? How do we find the sum through a specific term when we have an explicit formula? What did we learn yesterday that allows us to do that? The partial sum was when you already had the terms of the sequence. What did we learn yesterday that you could find partial sums, but if you have the explicit formula? Summation, big E. So here's the point. I don't think we should learn another equation when we can utilize the equation we just learned along with what we learned yesterday in the big E. Let me explain. You see, this one doesn't want me to find a sub 10, does it? It wants me to find what? S sub 10. It wants me to find the sum through my
First to
10th term. So they want me to find the sum of the first through the 10th term. So here's what I do instead of teaching you another equation. 1, let's find the common difference. What's the second term? I know it doesn't have commas between it, but you still know what the second term is, right? What is it? 4. Minus what's the first term?
2.
What's 4 minus 2? So we're going to find an equation using a sub 1 We already know this equation. A sub 1 plus n minus 1 times d 2. We're going to distribute that common difference. What is 2 times n? And what's 2 times negative 1? We always start with our variable part, 2n. And what will happen to 2 minus 2? There's my equation that we just learned how to write. I don't want to teach you another equation because how can I now take that explicit formula and find the sum through the 10th term? Huh? 2 times 10 would just find a sub 10. We don't want to find a sub 10. We want to find s sub 10. Remember, a sub 10 is just, hey, what's my 10th term? Plug in 10. They want me to find s sub 10, the sum through my 10th term. So what can I do? You can go to your calculator. You can type in alpha window number 2. You can define your variable. And what would be your first term? 1 through what term? 10. So we find this s sub 10 by finding the sum from the first to the 10th term for this new equation we came up with that matches this sequence, 2x. I just changed the end to an x. And then I push equals. And what does it give me? So it's silly, in my opinion, to learn a new equation when you can use the equation we just learned along with your summation button in your calculator. Okay? Are you with me? This is not hard, right? Because it's still just one equation. The difference is they didn't ask Kaden what a sub 10, they asked what s sub 10. Can y'all distinguish those two in your brain? A sub 10 is when they want just the 10th term. S sub 10 is when they want the sum through the 10th term. So that's when we know to use summation for the same equation. You with me? Yes, sir.
On the expression below, x equals 1, will that always be like x equals 1 and the top number will be s?
Yeah, whatever that, yeah, exactly. Because it'll always mean all the terms through the 10th. So you got to start with the first one. You got it. So let's do one more of these, and then we'll go to the top. Y'all, 15 and 16, I don't have to do those with you, do I? I mean, y'all just type them into your calculator. So 14, they want us to find s sub 8, the sum through the 8th term. So we know we need to do the sum of all my values from the 1st to the 8th term. We just need a what? We need an equation. We need an explicit formula that represents this what? Sequence. Very good. So, let's find the common difference. What's my second term? Minus, what's my first term? Negative 6 minus a negative turns to plus. What's negative 19 plus 6?
Negative 13.
So there's my common difference. So here's my equation. A sub n equals a sub 1 negative 6 plus n minus 1 times negative 13. What are we going to do first? Distribute. What's negative 13 times n? Negative 13n. And what's negative 13 times negative 1? Positive 13. We always start with our variable, negative 13n. And guys, what's negative 6 plus 13? Not negative 7. Positive 7. So, what equation am I entering in here? Negative 13x plus 7. And you just push enter. And just like that, it spits out the answer, which is what? Negative 412 is correct. Questions about that? Again, I don't have to go through 15 and 16. It's already done. So now let's go up to the top. All right, so directions. If the given terms are part of an arithmetic sequence, write a rule for the sequence. Guys, what do I need to know to write the rule for the sequence? I need to know my first term, and I need to know my common difference. How did we say we found our common difference? Yep, second term minus first term. Well, what's the problem with that on number 11 and 12? You don't know the second term. Look, 11 gives you the first and the third term. 12 gives you the first and the 24th term. We need to know the first and second term to find the common difference. Not really, okay? So to find the common difference, if you don't have a sub 1 and a sub 2, here's what you do. Ready? You take the difference of term values and you divide that by the difference of your term numbers. Whoops, didn't mean to do all that. It's the difference of your term values divided by the difference of your term numbers. So when I don't have my a sub 1 and a sub 2 and can't find my common difference, this is how I'm going to do it. Now look at these with me real quick. Look at number 11. We got two different things every time we have a term in a sequence, right? We have the term number and we have the term value. On number 11, which two numbers are the term values? 3 and -7. Those are the term values, correct? Which makes what my term numbers? 1 and 3. Correct? All right, now listen. When it comes to finding the difference of these two, order doesn't matter, but it does matter. Here's what I mean. I could go the top, the difference of the term numbers or term values. I could do 3 minus 7, or I could do -7 minus 3. I can do either direction. But here's where it does matter. If I go 3 minus -7, I have to go what? 1 minus 3. Or if I go -7 minus 3, I have to go what? I have to go 3 minus 1. So order doesn't matter, but it does matter. It doesn't matter in that you could go either way. It does matter in that they have to match up. Do you understand? Watch what happens when we do it this way. What is, on this one, what is 3 minus -7? It's positive 10. And what is 1 minus 3? It's -2. Guys, what's 10 divided by -2? -5. Guys, what is -7 minus 3? -10. And on the bottom, what's 3 minus 1? Positive 2. What's -10 divided by positive 2? See, either way, you get -5. So, it doesn't matter which direction you go, but it does matter. Does you understand what I'm saying? So, from this point forward, simple problem, right? Y'all tell me, what do I do? What's the next thing I need to do? It's said to write or what? So what's the next thing I need to do to write a rule? Equals a sub 1. Do we know that? 3 plus n minus 1 times, which is what? -5. We just found that to be a -5. What are we going to do first here? What's -5 times n? And what's -5 times -1? Positive 5. So we're going to bring down the -5 in. And then finally, we're going to combine our like terms. 3 plus 5 equals. So my equation that represents this sequence is -5n plus 8. What do I do last? Find a sub 12. by going negative 5 times 12 plus 8. Negative 5 times 12 is negative 60. Negative 60 plus 8 is negative 52. Done. So even if you don't have the first two terms, can I find my common difference if they give me random terms? Sure, look at number 12. And I'm just going to find the common difference, and then we're going to move along. Remember, the top is the difference in your term values. What are my term values here? Does it matter which way we start subtracting? So do y'all want to do negative 17 minus 6 or 6 minus negative 17? So negative 17 minus 6 is what I heard. But because I went negative 17 minus 6, I've got to go 1 minus 24. Y'all understand that? The importance of that. So negative 17 minus 6 is negative 23. On the bottom, 1 minus 24 is also negative 23. What is negative 23 divided by negative 23? So your common difference here will be a 1. Okay? No matter what direction you went, your common difference here is a 1. Questions with arithmetic sequences and series? Yes, sir. Can I finish it?
No, if you like do it the other way around, if you were to do 6 minus 8.
What'd I say? It doesn't matter, but it does matter. If you do 6 minus negative 17, you got to do what? You got to do 24 minus 1. So if you change the order from what we did, that's fine. But you got to change the order of both of them. That way you're comparing apples to apples. And you're not comparing apples to oranges. Does that make sense? So your homework, which really is right now work, you can probably finish a lot of it, right? What time do we get out of here? I got a lot of time, actually. Y'all got like, 8 minutes. Y'all's homework is 2 through 20 even. Grab 2 too many. 2 through 20 even. Remember that time you listened to me good? Huh? You don't remember that time? I don't either. Remember that time you asked that random guy if you could use the restroom?
Where was she at? Where was the lady at?
The lady who's your teacher?